Okay, welcome again, everyone, to the June 22nd edition of the TVM and community meeting. We have a number of really interesting topics today that I will just share with you. Oh, this is the wrong. What are you guys seeing? I think the wrong. Are you guys seeing the agenda or the procedures?
Procedures. We can see the agenda. Oh, we see procedures. Yeah.
Okay, then it was the wrong one. I'm sorry for that. Okay, now it should be the right one.
Yep.
Okay, we have a number of really interesting discussion topics today. So one is one Sebastian brought up, which is the general structure of generated C code based on a use case example, which is now in a PR already, and where we can show some examples. But before we come to this topic, I want to ask into the audience, is there anybody who is new here and wants to introduce him or herself for the first time to the group? Okay, good. I thought I know most of the people, so we're good here. So then a few announcements. So we have a number of new reviewers. So congratulations to Denise Kutnik from OctoML, to Valerie Chernoff, and Alexander Peskov. So great achievement, and thank you for your contribution to the community and the TVM code base. Second announcement, there is still help wanted for the CI monitoring rotation. So if you're interested, I think just click here and add yourself, if I remember correctly.
Yeah, you can just go to that link and comment on the issue, and we'll put you in somewhere. So
yeah. Sounds good. And announcement number 3, there's going to be a release 0.90. So let me show you shortly here. So there is going to be a couple of new things. Does anybody want to comment here? I wasn't really involved in creating it.
Angie, we can't hear you because of your microphone.
Guess I didn't fix it after all. No?
It's good.
Okay. So much for fancy mic. Yeah, I mean, I can say something, or David can say something too, but yeah, we're going to follow this new quarterly release procedure that's been approved through RFC. So you can kind of see the schedule that comes out of that. If folks are interested in contributing to further testing the release over what the TVM CI would contribute or provide, there's a window in here basically for folks to propose fixes and get in any last cherry picks that we want to apply to the release branch. I think the rest of the process is sort of attempted to be inherited from the previous one, and just we kind of wrote it up kind of based on what we understood. So hopefully that's approximately right, and we may make adjustments to this particular release process as we go forward. But thanks, David, for commandeering the release here.
So next week is the branch cut day, June 28th, which we're just gonna take main from that day, and that'll be what the release is based on. So this couple weeks afterwards, if there's anything else you want in the release, you just let us know and we'll manually add it. But that's the plan right now.
Sounds great.
Yeah.
Cool. Okay, so much to the release. So before we get started with the first topic, is there any other topic somebody would like to discuss today that we should add to the agenda, or any other news announcements? from the community? Anything last minute? Okay, good. Then I will hand over to Sebastian for the discussion on code structure of generated C code.
Okay, yeah, thanks. I think that this title is a bit hard to imagine what we are talking about. I think the topic that I want to address is that sometimes pretty tiny changes in the code base seem to affect what we in the end get on the C code level massively. And in this case, it was a new implementation of concatenation for CPUs. I can actually show you this. And what I would like to achieve is to have a first discussion on how could we maybe get an improvement here such that something like this is at least detected during the review process to help. I mean, I know things like this are super hard to test in a specific way, but for us it's really, it would be very, very important to have something where we can more easily track changes like this. Can you see my screen?
Just coming up.
Okay, great. So this is just from one of our networks. The same layer before and after PR 11800. 11800 was by me. This is just a small fix to another PR that changed the implementation of concatenations. And I think the idea behind this is perfect. It's exactly the right approach. But still, if you just look at this, I mean, the old version was more or less a one-liner, and this is the new version. And the new version allocates 4 additional USMP buffers and does many things that are mathematically not necessary. And Michael and me spent maybe 3 hours already or so together with colleagues, with Ulrich and Koi, and we still don't figure out what happens exactly. This is very difficult. But the real issue is how, if folks have any idea on how to make it easier in the review process to see such things. I'm also not aware how relevant this is for other people. I mean, we are a bit special there. We actually have people that look at our code, that take the code and that take the same model 2 weeks later, create new code, and they will ask us really interesting questions if they see changes like this. So for us, this is a huge problem.
So maybe to give some more context, so Sebastian, if you go up, so line 5, for example, line 5 is a one-liner, but I would assume a very long one-liner, right?
Yeah, but it's, I mean, basically it's the idea of this PR was to get rid of this if then else chain in concatenations. So here these are just 2 arrays. There it's still okay. If you have more than 2 arrays, then this is a chain sequence of if then else statements. So it's a ternary operator that has another ternary operator inside and another ternary operator. So what you actually get is a set of 4 loops that does the same thing. And this is, I think, clearly better. So that's all cool. The problem is that you get all of this for free too, which is not so cool. And I mean, it's really 2 points of this discussion. The one thing is, of course, in this case, we hope that we can simplify this. But the other thing is there a way how we can make the tests or the review process in a way such that things like this are at least detected? I mean, what we typically do is really just, we just print C code. And we just compare C code between iterations. But of course, this cannot be a test. You cannot create a unit test that tests for identity of 2 generated codes. That's way too strict. One thing, for example, that we can do internally is like, okay, this is the old version, this is the new version. Is this okay? Is this something that you would expect as a change? And then at least ask questions on why things have evolved this way. That's one possible idea that I have, but I know it's a bit difficult, and especially also with all the other targets. I mean, most people probably take LLVM. I'm not sure if someone would be interested in comparing LLVM code,
So,
or if it's. Yep.
sorry, just I think that this might be easier to test than at the TIR level, because if these are all specifically placeholders that have been pulled out prior to the concatenation, then let's see, after lowering but before the different inputs have been merged into a single array, then that might be a good point to have some sort of a test there to say how many different arrays are allocated, because at that point they would each have a unique allocate node, where I definitely agree that if you wait till the very end of the process after they've all been merged into a single allocation, unless you know a priori exactly what size you expect for a single size, or for a given workload, which starts striking me as a pretty fragile test if anything improves as well. But number of, say, allocations before those allocations are merged might be a easier way to place a test, at least for this specific case.
Yep.
So what is it specifically that you don't like about this code?
I mean, there are many things. First of all, it's super long, but it's also what it basically does is it copies, for example, this input to another array that it then uses to concatenate. I mean, it could directly use this, for example, here. It makes many unnecessary copy operations. I mean, what you typically would do to concatenate is just write the placeholder here and the placeholder. I think in this case it's actually maybe it's padding zeros, so you would actually just write a 0 here and placeholder J here, and that would be it.
So is it basically that it's suboptimal?
It is suboptimal, yes, and I mean, it's really, as I said, one thing is the code itself, but the other thing is that it's very hard to detect such changes with the standard unit test base. So
Well,
we
okay,
get these.
hang on. So we're using C here as kind of an output language, right? Is it so? It's kind of like an assembly almost, and so it's never going to look like code that a person has written, because this code is not meant to be maintained. It's not meant to be readable.
Yeah, of course.
And it's so if you partition the original code into many different pieces, then you're going to end up with something like this. And so what I'm trying to understand here is whether it's worse in terms of performance or whether it allocates too much memory, because those are the things. Those are the things that we can optimize for. Now, about the code actually looking one way or another or being long, or I mean, code size. Okay, yeah, code size does matter, but we need to have some specific metrics that we're trying to address. What I've heard from you is sort of a lot of kind of personal opinions about what the code looks like.
Yeah, okay, maybe I can be more precise. It's not only personal opinion, because you don't need anything of the code that from here to line 66.
Okay, so what does the C compiler generate out of this?
I haven't even looked at it, but it's
the
thing is, all of these, like initializing these zeros to this array is not necessary. You could have them directly here. Copying the input to this array is not necessary. You could have the input directly here.
Well, okay, but what does the C compiler generate out of this? That's the question, because that's the code that's going to execute.
Yeah, I think there is in the PR, there is a screenshot of a performance metric somebody made.
Yeah, I mean, the performance with this is better than in the old version. That is true. I did not look at the generated code. Like, I did not look at the compilate.
Yeah,
but it's
one thing I would note here is I do in some sense agree with Christoph in the sense that we should I think there is probably a reasonable concern here. We should make sure to express it in terms of thinking about the question of how do we write a test that would, you know, kind of protect this in regression. I think that what Christoph is sort of trying to say is that we should identify some, you know, some metric that we can then test against, basically. And I think that one use case that I kind of note as like if someone's a sort of using this in a deeply embedded scenario is the use case where you want to compile but still enable debuggability, basically. And so in that case, you may disable full compiler optimizations. And you know, we have had cases where you can compile something and you can fully optimize the compiled artifact, but then if you actually enable debug mode, you actually can't debug it because it doesn't fit on the device anymore. And that's because the compiler didn't elide some unnecessary arrays. So I think that there are, you know, I think that there are both, I think we can probably come to some metrics here, but I think that there is a use case, basically, I guess, a use case specific metric that we might need to think about here. Should we keep talking here, or do we want to allow folks who have had their hands up to maybe?
Maybe let's try to collect more opinions and then dive deeper into the discussion. So, Manupa and David.
Yeah. So, right. So my 2 cents around this, I would call this something as what is called a fake fusion. So if you look at the function signature, it mentions the operators that are supposed to be fused, which is returned from the fuse of parse. And after the change, it seems like the fusion hasn't happened. So all these for loops should also be visible in TIR if you look at that level. But before the PR, the fusion has happened successfully. But yeah, metrics might seem differently. I'm not sure about which is faster and which is not faster. But there are obviously implications if the compiler's expectation is to fuse and the fusion hasn't happened. And in this case, it seems like we are using USMP, so it might be less of effects. But if the TR allocate node remains, which are kind of compile agnostic and handled in the runtime, no compiler will be able to optimize that away. So I guess coming back to what Andrew's case, if you want to keep the debuggability, then you should probably reduce the fusion of levels, and we should keep them separate. And I think these loopness correspond to each of the operators mentioned in the list. So this is an issue. We have seen similar issues. We have raised that before. This happens to various things, but looking at the change, something changed in the TE is kind of stopping the dependency exploration done in the compute inline paths. That's my read of it. But I'm not sure what kind of tests should be there to ensure the proper fusion happens.
I mean, for one point, one thing that would be possible is here to check the memory footprint. I mean, if you look at the version in line 3 and version in line 11, one direct test would be to check the allocate nodes. And if there is a minor change, this should not happen, should it?
Sorry, go on.
I think there was actually a test in the original PR where the global workspace size increased quite a bit with this change. So this was actually detected by a unit test.
Yeah.
But then I think it's also very hard for a reviewer to see whether this is needed or is if it's justified or not. I think in this case it's not justified. But yeah, I agree. I just wanted to point this out. Please don't I don't expect to get a good answer or anything, but also it's really not, to make this clear, it's not about the aesthetics of the C code. I cannot imagine that a compiler can optimize away everything that is in there that is not necessary. I mean, all these pointers and buffer accesses, which compiler would be able to optimize this away?
I totally get it. Yeah, I totally get it. It's just that I wanted to focus on what specific things are about this code that we can try to target to optimize away or improve. But you know that somebody, I didn't notice who that was, but somebody asked a good question or made a good point, saying, well, a small change here should or should not create a bigger change downstream. And I think that question is very difficult to answer, because as compilers get more complicated, different analysis will cross different thresholds, and they will make different decisions that will then cascade into a sequence of transformations that wouldn't have happened otherwise. And you know, whether this is always a difficult thing, and it's very, very expensive to look at changes like that and you know and try to understand why they actually happened. And usually, in my experience, those are typically triggered by something else failing about the code. Let's say the code size increased dramatically, or performance degraded, or memory consumption has increased beyond certain threshold. Like in general, it's difficult to notice in the first place, unless we are watching something that would tell us that something is wrong with this code. And so, like I mean, I agree that in general we could probably make the transformation from the final TIR into whatever underlying IR is, that we could maybe have some kind of a additional optimization passes. That because the changes that you are just describing here might actually also be helpful for the LLVM codegen. But it's you know, what I'm concerned about is how do we algorithmically decide what to, you know, when we need to change something, or what is it that we need to look at?
Yeah, I don't have a good answer. I mean, that's pretty clear. I'm totally aware that this is super difficult. Yeah.
Okay.
So
David, I think you also wanted to make a point.
Yeah. One thing we can do to just kind of address Sebastian's concerns about like knowing something happened in a review is a way of writing the unit tests or whatever tests. So like the generated code is part of the test. So we do this kind of like strict test that you mentioned earlier, Sebastian, where you like literally check the text of the code before and after. But you also make it really easy to update that with whatever the new code is. So then somebody makes a change, you can go see in their PR like a diff of what happened in the generated code before and after. So it doesn't actually fix anything, but it just like surfaces the like end-to-end result.
But if someone, okay, but if someone who's unfamiliar with this particular architecture makes a change, say in TE, and they run the test and they see that the output has changed, how would they decide that this change is acceptable or not?
Yeah, I mean, that's like another question.
Yeah, one like thought I had on this, you know, so far is that we basically have this tool that translates kind of these very high level graph specifications into essentially what should boil down to TIR before it hits a particular architecture's codegen. And you know, at the point in time that it hits an architecture's codegen, you know, I think that anything below TIR, you know, is something that, and here by that I mean like the codegen and sort of like everything that happens at runtime. I think if you weren't very familiar with the particular architecture you're compiling for, it would be pretty hard for anyone to, you know, assert basically what's a better change to, or what's a what's an improvement versus a detriment to that part of the code base. In other words, like folks that operate kind of below the TAR generally kind of have to be more familiar with that hardware platform, and to some sense that we could consider that to lend a bit of ownership to that part of the code base. And so, maybe there's something to be said for sort of, what the tier looks like when we're all said and done with TVM's optimizations, and then, what code is generated kind of there on below, just thinking of a possible way to kind of split this. The other thing I was thinking of was that what we could do is we could have a tool, and I think this is similar to what I can't remember actually who said it at this point, so I'm sorry. There've been a lot of different folks chatting this time, which is great. But we could, run a set of example workloads on various backends, not necessarily run them, but code generate them, and then generate a report page in the CI and basically highlight the differences. Automatically search for the differences between the last known good build and that PR, and then surface the the differences just in a typical diff style. So those are my two thoughts so far.
Yeah, that sounds, for me, that sounds like a really cool idea.
One of the things with the diff style, to Christoph's point, is, sorry, I think it was Christoph's point, is how would we, how would anyone modifying one of these unit tests know what's better? Maybe if it's not a unit test, but it's a part of the CI report, it's a reason to either trigger a view from someone who's familiar with that particular target, or even just CC them. But it can also sort of just be something that could be watched. I think it would be important to make sure that if you're kind of maintaining a particular backend in TVM, that you have adequate ways of knowing what's going to be changed basically on you, so that TVM doesn't just sort of pull the rug out from under your feet. I don't know if anyone disagrees with that here or agrees with that here, but I'm curious to know what people would like in such a tool.
Yeah, I think we go back to what is it that this tool should show to you? Because one thing we could do is have some kind of a tracking that measures, say, the amount of static allocations or code size or whatever, and have some kind of a graph that's associated with that associates a value with each commit, and then we can see how that progressed over time, and if we see some kind of a increase that seems problematic, then we can go and look at that commit, see what it did, or we can block the commit until the code owner agrees. But so the second one would definitely slow things down. The first one has the problem that what does this tool need to look at, and so I think that's the hard part to see or to decide what is it that we want to track about the code.
Or sorry, what did you mean by the second and the first one there? Just so
yeah, so the first one is that we don't look at each individual that each polar, like we don't track, we don't have tests that are meant to fail if something changes in the output. We just have like the regular tests that check for correctness or maybe some sane output, that sort of thing. But at the same time, we collect some statistics about what the code looks like, some properties of it, and we have some other, maybe some kind of dashboard somewhere where we can see the graphs about how much the static memory allocation changes on a particular test case over time. So that's one thing. That's kind of a passive thing where we can go back and look, okay, where did this change happen now that everything takes 1 megabyte of extra memory? Or we can do the second approach would be to basically have tests that stop, that basically block commits if anything changes, and then have an explicit approval from the maintainer, the backend maintainer, to adopt that change, to accept that change as reasonable, or investigate what happened. And I think So the cons of both are that the second one would be very slow, and the first one has this issue that, you know, what is it that we are tracking?
Yeah, or you can have a mix of both. So having like a threshold, so keeping a history of known use cases, like saying ResNet or whatever takes these kind of metrics over time, then you can see how it changes with each commit. And having like a threshold. So if for some reason this goes up in one use case by 50%, then it is required for someone to allow such a merge. Maybe some mixed mode could be possible here as well.
Yeah, I agree, and I also think that it could be potentially target specific. And you know, the real question is, I think to Christoph's point about slowing things down, is that I think the question there is what is the policy around such a tool? I think it's, you know, fine to have a tool kind of in an advisory capacity. For example, I once worked on just a website that was, you know, just kind of a full stack site serving system. And what we would do before we committed each change is we would run a visual diff tool that basically would go to each page as Chrome and then take a snapshot of it, and then it would just generate a report. And, you know, you could look at the report, you could not look at the report, you could kind of do whatever you wanted to. But if there was a change, then there's a way by which we can easily go through and find, you know, what patch changed this. I think that a compiler is a bit more complex than a web serving system, but there are some similarities in the sense that you can make a fairly innocuous change upstream, and that can lead to a, you know, drastically different page render. And, you know, here it's the same sort of thing where you can make a fairly innocuous change to a TE schedule or something like that, and it can drastically change the code output. So it seems like having some way to surveil the generated code would help, whether that's metrics or you know, some kind of diff tool or something like that.
Yep, I really like that idea. So basically have a low burden for creating a report. So anybody who wants to look at it is free to do so and can see the direct implications of a change. And as Christoph mentioned, sometimes there are optimizations that end differently than you would have thought when you introduced a certain optimization function. And then this could at least be looked up in an easy way. Cool.
Yeah, thinking a little bit about this stop fusion thing, because I think Manupa kind of brought up, you know, his opinion of kind of what was going on here. You know, one way we could do this is we could have, just thinking about how to like surveil this particular problem. I think if you just look at the diffs, you know, you could catch something, you know, fairly easily there, just because it looks so drastically different. But then you'd have to go look at the diffs. I'm wondering if, like, looking at this particular problem, if looking just at the buffer sizing is enough, basically, or if we'd want to export some information from kind of upstream in the compiler to indicate whether or not fusion occurred and kind of what was done.
So I think while I appreciate the general requirement of having some kind of regression test on model basis probably might help us to indicate the ISN problem. For this particular case, I think if we had few test cases with relay operators, sequences of relay operators, and maybe of exploring the TE produced after TE compiler and calculate maybe the loop nests, would find that, and we can have an expected value or maybe with some bounds depending on how prescriptive the test needs to be. If they have some kind of testing, we should have been able to catch this, I would say.
Yeah, that makes sense. So maybe something for us to think about is kind of how we could better test these different compiler passes. And yeah, something we should get better at as TVM matures towards 1.0 for sure. One thing that we were kind of exploring with micro TVM was the ability to just take a relay operator or a relay graph and assert kind of end to end that the compiler chose a particular schedule, and that schedule performed well, basically. And I was curious if anyone else has run into this, sort of a need to ensure that a particular TE schedule remains, functional, basically, but functional all the way from the point of here's a relay graph and now optimize this and produce code. Anyhow, we're sort of exploring what to do with that test infrastructure and how to expand it. So, we could consider expanding something like that as well if that would be helpful. Yeah, maybe the correct thing to do here is to follow up with a little bit of more of a concrete proposal of what to do. I guess, is this something you guys are interested in driving, Michael, Sebastian, or what? How should we proceed
Yeah,
here?
I think we are the ones that brought this point up. So yeah, probably we should, but this will take some time. But yeah, definitely.
Yeah, no pressure. I think people are fairly busy, so and I don't think it has to be driven by any one particular. It can be sort of community driven. So, but I think it would be great to kind of assemble a little bit of a proposal there, and I'm happy to help there too. But
okay,
just want to. Awesome,
cool. Then we've brought up and also assigned an action item to somebody. So anything else that anybody else who wants to comment here? I think the discussion is almost concluded here on this topic. Okay, good. Then this was, I think, the last topic for today. Yes. Any other topics somebody's interested in? Okay, then thanks everybody for being here today, for participating, for the great discussion, and then see you again next week.
Thank you. Bye.
Bye.
Thank you. See you later.
And thanks everyone. Bye.